Let's talk about basic. Let's start. Let's talk about basic auth. Basic auth is easy to implement, but is not at all secure unless you're enforcing SSL or HTTPS if you prefer. But it's still risky. Because it sends the credentials on each and every request, it increases that surface area of attacks. It also means that people can get access to the browser, can get access to username and password. And of course, once they have those, they can try those same username and passwords on a bunch of other sites as well. So there's a risk here with basic auth of sharing credentials, not only to allow them to get into your system, but that might be used to get at other systems if they're not using good password practices. Token-based auth is the first kind of authentication and authorization that we're going to talk about that I recommend you using with APIs. There may be reasons to use cookies and sometimes basic auth, but token-based authentication is almost always going to be used with APIs unless you have a really good business reason to not have that level of security. Because these are typical for APIs, they're really a mix of secure and simplicity. The industry has defined standards for what tokens can look like, though you don't have to use the industry standard tokens. We'll look at what they're composed of and how they are secure. Typically, tokens should expire much faster than cookies. Typically, 5 to 20 minutes is as long as a token will work. There are different kinds of tokens, including a refresh token, and that just allows you to, within a time period, request another token to expand that period. So to the user, it might feel like they're logged in for a long time, but in reality, you're just saying, oh, we have an authorization failure. I'm going to call with my refresh token, get a new token, and then continue calling it. It does require a little bit more finesse to make token-based authentication, but in most frameworks that might use your API, they already know about this. It's a very well-known problem. So let's talk about how it actually works. So the client is presented and they're asking for some information from the user. So the client sends these credentials to the server, and once the server validates those credentials, it's going to send a token, which is essentially just a magic series of characters. It's not meant to be human readable. The client never needs to decode it for this whole system to work, though in many tokens, the client can securely look at the information that's in it. Then the client is going to use that on all subsequent calls. And as long as the token validates, it'll complete that request for it. The most common type of token you're going to see are JWTs, or JSON Web Tokens. This is an industry standard that is used by a lot of organizations. The token itself contains the information about how it's secured, what the information about the user is, and it's a complete package. This includes user information, claims to know what the user has access to, and then something called a validation signature. You can store other information in these tokens as well, though when you design security for your API, you're going to want to think about what information that's in that token will be useful to store and secure to store, because remember that tokens can be taken and decoded. Let's talk about the structure of a JSON Web Token. So the string on the left is that magic string that is the token itself. And I'm using a tool here to decode it. And the header has some metadata about the token. In this case, what algorithm is it using, and possibly even what token type it is. But in our case, it just has the algorithm, so it knows how to deal with the cryptography part. And the token itself is just stored as the beginning of that token. It ends with a period. So there's these three sections that map to header, payload, and verify signature. So the second section here are the pieces of data that are useful. And you can see some standard ones like EXP is for expiration, username is who represents this object, and you might even have role or issuer information. That's represented by the purple section here, of random numbers. Now, because this can decode them, this implies something that it doesn't require anything to look at this information. The magic really comes in the signature. Now, this signature says no one has changed this token. No one has tried to apply that they have more rights or that their username is different or that the expiration is longer than it should be, because the first two sections are taken and then run through an encryption algorithm with a key. And that key is something that only the server knows about so that it can validate this token is still the same token it issued. And the primary concern of the JWT is not protecting and encoding information so people can't get at it. All the information in here should be safe for users of your API to use. All you want to do is have your API verify that this signature matches the rest of it. So it becomes a self-contained bucket of trustable information. If you haven't looked at tokens before, a lot of people might assume, especially with this format, that this is encrypted in some way, and it isn't. The only reason we have these first two sections in a more cryptic way is for size. So each of them is base 64 encoded. So as long as usually the server knows about the key to that signature, then we can say that the signature is verified. Now, these are a lot of specifics that probably your backend code platform, whether it's Java or C# or Node, they will take care of all the semantics for you. You're not going to have to design how all of this works, but it's important for you when you're considering designing your API about how you're going to do authentication and authorization to understand what it looks like. And finally, let's talk about OAuth. The idea behind OAuth is to have a trusted third party identify users so that your API doesn't necessarily need to understand who they are. They're just taking the information about who they are from a trusted source. Your API will never receive the actual credentials, just the metadata about that user. The user is authenticated with some third party and then will send you the token to use. This token is used to confirm their identity, and it is safer for you because you never get a hold of those credentials that really belong to the user in this third party. Think Facebook login, Google login, Microsoft login. But how does it really work? So the developer themselves requests an API key from whatever this third party is. And that API key, along with the shared secret, is used by the API. It requests a token, and that information about the developer is then validated and then returns a token, which is going to redirect the API to some authentication URI that will display the authorization UI, and then the user can confirm the authorization. So there's two pieces here. One is logging in with the third party, then it's often, almost always, going to confirm that you want the developer to have those rights. You've probably done this a million times when you've logged in with something other than a database stored username and password. Once the user confirms that, it sends this back to the developer, and with that information, they can request an access token, usually a JWT. And then they can return the access token to the API, and then the code behind that API can use that API token until the timeout. So the developer, in many of these cases, is going to be the person writing the website, and the API is going to be the thing you're designing for. Again, this whole workflow is important, but there are going to be frameworks or tools that are going to do a lot of this hard work for you. And this should imply something, and that is getting authentication and authorization right and making sure it's trusted is hard. There's a lot of moving pieces that have to go together before you can be really happy that you have an API that is secured and is also not liable for the credentials of users that are authenticating from a third party. So OAuth is a great solution when you don't want to be responsible for implementing the security yourself. And again, this is a design decision that I think should be part of developing the API. If you want this level of security, please don't make it yourself or create it by hand. There are plenty of solutions for doing this, and instead you can trust secure third parties. So Azure Entra ID, Okta, AWS has one, Google, Facebook, Twitter. You can really rely on them to handle the hard part of security. That way, organization doesn't have to be liable for that. Let's wrap up this module. So, what have we learned? We've talked about considering security while you're designing the API. If you don't, you're going to just have to layer that security on top. That might change the way that your API wants to work. Are you going to send that information in a header as a token? Are you going to hopefully not pass it in as part of the API? Those are considerations during the design part that you have to really think about. You should have an idea what your security requirements are. And if you don't have that idea, you need to do that gathering of requirements to really understand how secure this has to be. There's always going to be a compromise between complexity and cost and security, and you need to figure out where that balance is. And at the end of the day, I want you to be pragmatic about security. Don't assume every app needs to be on an unplugged PC off the internet, because that's the only way to really keep it completely secure. You need to think about what is the risk of security failing? What is the risk of people getting in and having that and getting at security information, as well as the complexity for the people using your API to handle authentication. So this is the end of the course. Thanks for joining me. Hope you've learned a little. Remember to use the discussion tab to ask questions. I'm fairly active on that and can answer questions as quick as possible. I'm happy to have those conversations to help you design the best APIs that you possibly can. Again, this has been Sean Wildermuth for Pluralsight.